In this video, I will work out some examples of simplifying expression using exponent rules. I will start by reviewing the product rule. Say that when you multiply two expressions with the same base, you added the exponent. The quotient rule says that when you divide two expressions with the same base, you subtract the exponent. The power rule says that when you take a power to a power, you multiply the exponent. The power of zero rule says that anything to zero, the zero power is 1, also long as the base is not 0. Since 0 to 0 is undefined, it doesn't make sense. Negative exponent to evaluate to x to the minus n, we take the reciprocal 1 over x to the n to evaluate a fraction exponent like x to the 1 over n. We take the nth root of x. We can distribute an exponent over a product times p. A times p to the n is equal to a to the n times b to the n, and we can distribute an exponent over quotient. A over b to the n is a to the n over b to the n. In the rest of this video, we will use this exponent rule to simplify expression. For our first example, we want to simplify 3 times x to the minus 2 divided by x to the 4th. There are several possible ways to proceed. For example, we could use to the negative exponent rule drx to the minus 2 as a 1 over x squared. All that gets divided by x to the 4th. Still, notice that we won't take the reciprocal of the x squared. The 3 stays where it is, and that because to the exponent of negative 2 only applies to the x, not to the 3. Now, if we think of 3 as 3 over 1, we have a product of two fractions and our numerator, and we evaluate that by taking the product of the numerator times the product of the denominator, which is the 3 over x squared, all divided by x to the 4th. I can think of x to the 4th as x to the 4th over 1. So now I have fraction which I can evaluate by multiplying by the reciprocal. That simplifies to 3 times 1 divided by x squared times x to the 4th, which is the 3 over x to the 6th, using the product rule, since x squared times x to the 4th is equal to x to the 2 plus 4 or x to the 6th. An alternate way of solving this problem is to start by using, I can rewrite this as 3 times x to the minus 2 over x to the 4th quotient rule, that 3 times x to the minus 2 minus 4 or 3 times x to the minus 6. Now using the negative exponent rule, x to the minus 6 is the 1 over x to the 6, and this product of fractions simplified to 3 over x to the 6, the same answer I got before. The second problem can be solved in similar ways. Please pause the video and try it before again. And one way to simplify would be to use the negative exponent rule first, minus 5 at the 1 over y, the 5th. Thinking of this as a fraction divided by fraction, I can multiply by the reciprocal. Get 4 cubed at y to the 5th over 1 by the product rule. The numerator here is 4y to the 8, and so my final answer is just 1 of the 8. Alternatively, I could decide to use the quotient rule first. As in the previous problem, I can write this as 4 cubed minus negative 5 by the quotient rule, and so that's 4y to the 8 as before. I would like to show you one more method to solve these two problems, kind of shortcut method. Before we to go on that shortcut, realize the principle that negative exponent in the numerator. To go on that short reply corresponds to the positive exponent in the denominator. For example, the x to the negative 2 in the numerator here. After some main multiplications becomes as an x to the positive 2 in the denominator, negative exponent in the denominator, to the positive exponent in the numerator. So what happened when we had to the negative 5 in the denominator and translated into a y to the positive 5 in the numerator? Sometimes people like to talk about this principle by saying that you can pass a factor across the fraction part. We will use this principle again in the next problem. In this example, notice that I have y's in the numerator and the denominator, and also z in the numerator and the denominator. In order to simplify, I am going to try to get all my y either in the numerator or the denominator and y3 denominator. Since I have more y the denominator, let me move this y to the 3 denominator and make it at y the negative 3. I am using the principle here that positive exponent in the numerator correspond to the negative exponent in the denominator. Now since I have a positive exponent z in the numerator and negative exponent denominator, and I want to get a negative exponent, I am going to pass the z to the numerator. Add the minus to 2 in the denominator, it comes as e to the plus 2 in the numerator. Notice that my number 7 does not move, and when I do any of these manipulations, because it does not to have an exponent, applies to the z and not to the. Now that I have got all my z in the numerator and all my y in the denominator, it is easy to clean this up using the product rule, and I have my simplified expression. In this last example, we have complicated expression raised to the fractional power. I am going to start by simplifying the expression inside the. I can bring all my downstairs and all my x upstairs and get rid of negative exponents at the same time. In other words, I can write that as 25x. I all bring the y in the minus of the downstairs and make it y to the 5th on the denominator. Bring the x to the minus 6 upstairs and make it x to the 6th denominator, and then I still have the y cubed on the denominator, all that raised to the 3/2 power. Using the product rule, I can rewrite the expression on the inside of the parentheses as 25x to the 10th over y to the 8th. Recall that we are allowed to distribute an exponent across a product or across a quotient. When I distribute this half power, I get 25 to 3/2 times x to the 10th to the 3/2 divided by y to the 8th to the 3/2. Now the power rule tells me when I have power to power, I get multiply the exponents. So I can rewrite this as 25 to the 3/2 times x to the 10th times 3/2 of our y to the 8 times 3/2. In other words, 25 to the 3/2 times x to the 15th over y to the 12th. Finally, I need to rewrite 25 to the 3/2, since 3/2 can be thought of as 3 times 1/2 or as 1/2 times 3. I can write 25 to the 3/2 as 25 to the 3 times over halves, or as 25 to the 1/2 times 3. We using the power rule in reserve. I can think of this as 25 cubed to the 1/2 or as 25 to the 1/2 cubed, since when I take a power to power, I multiplied the exponents. 25 cubed to the 1/2 might be hard to evaluate, since 25 cubed as a huge number, but 25 to the 1/2 is just at the square root of 25, so I have the square root of 25 cubed or 5 cubed, which is 1 to 125. Therefore, my original expression is going to be 1205 x to the 15 over